won't be able to hear any of you guys. So like when I ask questions and you guys answer, it won't hear you. So again, today is Math 8. We are going to be working on exponent work, and I think we're ready to dive in. You guys have any questions before we get rolling? All right, in a couple minutes, I got to send it. There's Ivan. Now we have everybody here, and I can send attendance saying everybody is here. So give me 30 seconds to do that, and then we will dive into our exponent work. If I've not been annoying about this before, you should have colors to write at your desk. If you don't have any, don't go searching for the house right now, but especially by the time we're back in school together, my basic colors that I use through class are green, black, red, blue. So if you at least had these basic colors, now obviously I have more than that as we're doing all this work in Zoom. I've got literally, like, I keep them sorted right here beside my my little command center. But colors will help you tremendously. And reminder, I post our notes. Zoe's showing off all her colored pens. I post our notes on our Schoology page, so you can ask me to slow down as we're going, or you can always know that by the end of the week, I will post our notes on our Schoology page. Please refer to that when you need to. So since we're all going to be following along with the lesson, I should be able to call on any of you, and you should pretty quickly be able to unmute and either engage with me about that conversation or tell me pass. Remember, you're always safe to say pass here. So when we talk about exponents, well, we can probably guess that exponents are these little numbers up above the other numbers. But, sorry, I'm going to want somebody to volunteer and tell me what goes here. But a question that we have in the chat, if you did assignments before I assigned them, yeah, you do actually have to go back and redo them. This has been a change that has happened in Khan Academy. To anyone who's frustrated right now, like the person who I see obviously frustrated, I already announced this when we figured this out. If you work ahead of me, that's fine, but that doesn't mean that you'll get credit. So what I told you you can do if you're trying to do work on your own is in Khan Academy, if you want just extra practice and things to, I might as well just open a new tab, just things to work on, you can go to any courses, like say we're 8th grade math, and then it should pop up with like a course challenge or mastery challenges. That's what you can do if you just want to randomly work on stuff and get better. But if you already did, let's say the assignment that I gave you guys about exponents this week, if you've already done it before, you should be able to do it again pretty quickly. That's the point of mastery. So if you are truly mastered on something, like I think I'm mastered on installing toilets. So if somebody asked me, hey, Micah, can you come over and install my toilet? I wouldn't say, well, I've done one once, I'm never doing one again. That doesn't make sense. If you're mastered on something, you should be able to do it again. So I will make a small assumption here and say, Sebastian, I'm guessing that you know what to tell me goes here. So what's the purpose of exponents? Exponents are used to represent what? Apparently, Sebastian, well, maybe. Sebastian, can you unmute and chat with me about this? Or if you're still getting stuff ready, that's fine. Looks like Sebastian's still getting stuff ready. Colin, you're above Sebastian. Do you know what the purpose of exponents is? So I have written here, to efficiently show repeated... Close. So the first operations that we learn in math are addition and subtraction, right? How does multiplication relate to addition? Well, multiplication, sorry, go ahead. Did you say equations? Colin, put the knife away. Stop stabbing in the dark. You're stabbing in the dark. Have you ever heard that expression? Charlotte, you're right, but you're out in left field. You guys are all right. I love when you guys chime in, and what you're saying is right, but it's not what I'm teaching. Multiplication. Oh, I need scrap paper, and I don't even have scrap paper. Like 3 times 7 means I have 7 3 times, right? So multiplication is used to represent repeated addition, right? I have 3 7s. But when we turn to our exponent work, and since nobody can give me the answer, I'm thinking we should all be writing this down. What's that, Ivan? Yeah, it represents repeated multiplication. Exponents are used to represent repeated multiplication. For example, 11 to the third, 11 with the little 3, means 11 times 11 times 11. Now this gets really annoying when we have bigger exponents. Like let's say we flip this around and instead of 11 to the third, it's 3 to the 11th. That would mean 3 times 3 times 3. There are 11 3s here, right? Which I didn't plan that out very well. Didn't leave enough space on my paper. But this gets really, really tricky when we start looking at the comparison between expressions with exponents involving parentheses versus expressions with exponents not involving parentheses. Would anyone like to take a risk and tell me how these two expressions compare? Are they the same? Are they going to be different? Can we talk through what is happening here? Zoe?
So they will be different because the first one, negative sign is inside the parentheses. So when you multiply negative 4 times negative 4. But with the second one, you can multiply it will just be negative because there's no parentheses.
Yeah, the second one is the opposite of 4 times 4. So guys, this, and a couple of you have done the Khan Academy assignment, but I'm hopeful this will help save you from the trap door in Khan. This sort of problem is always where kids fall in the trap door. This is not negative 4 squared. This is negative 4 squared. Notice the pause. And guys, talking about math sucks. I'm just going to tell you that right now because the pauses mean so much. So sometimes to say the parentheses, we use a phrase called the quantity of. Hey, Kelly, while I love what you're doing, it's super distracting for me because I know that you're like, oh, with a drumstick, I could do this. I love what you're doing, but can you please do it off camera? Thank you very much. So this is negative 4 squared. The whole negative 4 gets squared. This is the opposite of whatever 4 squared was. So negative 4 squared becomes positive 16 because a negative times a negative is positive 16. But the opposite of 4 squared is 16, but then the opposite of that is negative 16. Questions about the comparison between these two? So then I'm going to start from Zoe and just work my way around the room. So beside Zoe is Sophia. Sophia, can you make a guess about what this is going to become? And remember, you guys can always pass. Yeah, because this turns into negative 1 times 1 times 1 times 1. But 1 times 1 times 1 times 1 is just 1. So our answer is negative 1. Besides Sophia's Audrey, what do you think about this one? Negative 9 squared. You're muted, by the way. I know you might just be thinking. So Audrey, do you know what 9 squared is going to become?
I
Yeah. Hey guys, reminder for everyone, you do not have to ask permission to go to the bathroom. For my class, for math class, just go. That's always my rule, even at Phoenix. It wastes more time asking and waiting. Just go, and when you come back, ask questions if you get confused and like missed stuff. So sorry, Audrey. Yeah, you were saying 9 times 9 is 81. So if you're one of the people who has to go to the bathroom, go. Just go fast. So 9 times 9 is 81, but the opposite of that, so this will become negative 81. Now this is different because this one has parentheses. Well, Ben was the next person. AJ, do you know what this is going to become? You guys are more than welcome to pass. I just try to interact with as many people as I can. Cooper, do you know what negative 8 squared is going to become? Yeah, because it's negative 8 times negative 8. It squares the whole negative 8, and it becomes a positive 64. And we'll do one more of these. Sorry, that's an 11. Just it's like a fancy 11. Nick, can you unmute? You don't have to turn your video on, but can you tell us what this is going to turn into?
Negative 121.
Yeah, negative 121. Thank you for not saying and. There is no and until the decimal point. This is not 121. That's wrong. Anytime anyone says that on the TV, I throw something at the TV. No, I don't. I like my TV. But guys, there's no and until we get to the decimal point. So please, with big numbers, don't say and. There's no and there. Now, sorry, before I move on, any questions from integer base exponents? Which, by the way, if you want to label this section, it was integer base because the base was an entire number. By the way, we should write this down. All exponent problems are set up base value, and the symbol we use mathematically is the upward caret. Base raised to the exponent. So base is the thing being raised to the power. So my base is 11, my base is 3, my base is negative 4. Here my base is only 4, and then the negative gets applied. Here our base is only 1, our base is only 9, our base is actually negative 8 here, and our base is 11. The negative comes after. So if there's a negative out here, it's not part of the base. If it's out front, if it's in the parentheses, it is part of the base. So non-integer means non-entire number, right? Partial numbers, fractions, decimals, things like that. Guys, hear me when I say this. Decimals raised to a power suck. Don't do it. Use fractions. And I know some teachers won't use the word suck, but quite honestly, I don't think it's like a bad word. If you would like me to not use it, please let me know. I will come up with another. I can use like kid words like poo poo or is stinky is stinky, or no thanks. We are the 2-year-old that we hang out with. We just always say no thanks. So yeah, decimals to a power, no thanks. We want fractions to a power. Here's why. Even this mixed number, not doing it, no thanks. What I will do is convert my mixed number into an improper value so that it's just one fraction, not a number and a fraction. Then the way we deal with rational exponent problems, by the way, non-integer, these could also, if you want to name it a more particular name, you could call it rational exponent work. We square the numerator and square the denominator separately. Pause. It doesn't matter where the negative is. So I've had people both in chats and things like that, working with me at AO, ask, well, does the negative go on top, out front, or on the bottom? It doesn't matter. What matters is we're taking a negative number and squaring it. A negative times a negative makes a positive. So our answer will be a positive number. It does not matter where we put the negative, whether it was on top, out front, or in the bottom. Then we have to think about what is the numerator squared? What is the denominator squared? So we separately think about 9 squared and 2 squared, which is 81 and 4. I don't think that can be reduced. Any questions on that one? Now, before I totally forget, because we have about 20-25 minutes left and I have a lot more teaching to do, if I read your name in a moment, which, guys, it's a lot of you. If I read your name, you're about to have another missing in math for me, unless today you do what you didn't do last week. Can Zoe or Sebastian or Rachel or Kelly, because all of you did what you were supposed to do, tell me what I asked you guys to do on Thursday that apparently none of the rest of your classmates decided to do? Zoe?
I asked us to send you a screenshot of Khan Academy with saying if your brother needs help.
And 4 of the 21 of you did that. Not a good success rate, guys.
I thought you meant like if we're having trouble or not.
No. So, Dewan, you're throwing yourself under the bus. My directions were very clear. Everybody. I will give these directions again, but I'm not doing it again after this. Everybody is supposed to go to Khan Academy, go to your past work. So we go Learner Home. We click on Assignments. We go to Past. And however on your computer you take a screenshot, which I told you guys, go ask a parent or a sibling if you need help. Easiest way for me is hitting Windows Shift S, and I can use that snipping tool. So you're supposed to send me your past assignments showing me that you know how to get to this page, right? Then you send it to me. You just start typing Hudson in your email, right? If you start typing Hudson, I will pop up. You send it to me with a subject line of I'm good or I need help. So please do that today so I don't have to put a bunch of missings into map. And I will even wait 30 seconds in case you decide to go do it right now, but then I want you guys back to focus on me. If you already sent that email, you can go ahead and try to solve the next 3 problems that we have here. To get people's attention more so, those people that needed to send me an email is everybody except for Zoe, Sebastian, Rachel, and Kelly. Everybody else did not send me that email. Please and thank you. Akshaya, what do you mean? Oh, the screen capturing? You're going to need to ask somebody at your house how to do a screen capture on your computer. The reason I'm making this an assignment is I need to know that you guys can send me pictures of the work that you struggle with. So the point of us doing that is so that when you end up in Khan Academy struggling on something, that you would be able to send it to me. So let's say that this week you were in Khan Academy working on exponent stuff and you're like, yeah, I missed class or I wasn't paying attention or whatever. Let's say you're looking at an exponent problem. I could really quickly, dang it, there we go, take a picture of that, and that copies it, and then I can go drop it in an email and send it to my teacher and say, hey, I need help. And you could do that with a lot of your classes. You could utilize taking a screenshot. All right, back to our notes, because I only got 20 minutes left. So back to our notes. If I take this fraction to that power, what keeps happening? Guys, I think my TV's dying. My TV keeps cutting out. All right. Ivan, when we raise negative 2/5, sorry, I'm going to move this stuff off here. I don't know why that keeps happening. When we raise negative 2/5 to the second power. Ivan, you're muted. Ooh, you're so close. So remember, this would be, if I put the negative in the top, it'd be like -2 times -2. What's -2 times -2? +4. So be careful with that. We'd get positive, actually. And then you fell in the trap with the 5. Everybody falls in this trap. It's 5 times 5. Not 5 plus 5. It's 5 times 5. What's that? Yeah, 25. So this would be 4 over 25. Cooper. Might as well go from one Cooper to the next Cooper. Cooper Florence. What is this turning into? Yeah, so you want to go ahead and jump me to the answer. What's -5 times -5? 25. What's 2 times 2? Ah, that one. Oh, well, that would make sense if I flip this fraction here. Now, wait a minute. A third power. Bum, bum, bum. Guys, everybody come back to me. I can tell when I've lost some of you. Everybody come back to me. This third power, as some of you can guess, makes it -1 times -1 times -1. Sorry, these are not decimal points. I might as well just make the multiplication with parentheses. And in the denominator is 3 times 3 times 3, because it's repeated 3 times. Here's the dangerous part. What's a negative times a negative times a negative? Adam? Adam, you're muted. Sorry, you had your hand up, right? What's a negative times a negative times a negative? Or maybe you didn't have your hand up. I'm not sure. Yeah, when there are 3, it's negative. So this is going to stay negative. And 3 times 3 times 3 is actually 27. Here's the trick. I can't tell if I got a couple people upset or what, but if you need to put a message in the chat, please put a message in the chat to me if you want me to slow down or review something. Or you can just unmute and tell me.
3 times 3 times 3 is 18, right?
No, 3 times 3 is 9. Right, so 3 times 3 is 9. And then 9 times 3 is 9, 18, 27. So that's how we get that denominator of 27. Thank you for double checking my math. I often make math mistakes because I'm teaching and I'm trying to teach a specific thing and I just do the math wrong in my head. When we have a negative number, whether it's a fraction or whatever, raised to an even power, so like 2 or 4 or 6 or any even power, this is going to become positive. But when we have a negative raised to an odd power, when we have a negative raised to an odd power, it comes out negative. So that's the tricky part with these powers, is it doesn't always become positive. It only becomes positive if it's an even power, because an even amount of negatives cancel each other out, but an odd amount of negatives stays negative. Questions on the first page of notes we've taken here? Guys, I can see a couple of you look frustrated, but it's very hard for me because I don't want to call you out. Like, I don't want to call you like by name and say, hey, what's going on? But I can't tell what isn't making sense. Or maybe like you're just stretching and I just can't quite tell. But if you need to ask me something specific, the chat is private. Please use the chat. All right, if no one has any questions, I'm going to go ahead and keep moving. So now, if you want to draw a squiggly line or switch to a different piece of paper, we're going to shift into exponents that involve variables. Or variables that involve exponents. Depends on how you want to look at it. Now, before we talk about the variables involving exponents, we got to talk about the one caveat on, am I allowed to do this? In order for exponents with variables, or any, actually, exponents, I shouldn't have written this like this, but in order for exponents to be combined, this is really what I meant. The header is exponents with variables, but then I came down here and said, for exponents to be combined. Sorry, this is not very good note-taking. For exponents to be combined, the bases must match. For exponents to be combined, the bases must match. Here's why. When you look at 2 to the third power, Maya, if I asked you to expand 2 to the third, that means tell me what it is with like the times, like give it to me in the expanded form. How many 2's would I see here? Like when I do 2, sorry, go ahead. Yeah, and how many 3's would I see?
4.
Yeah. 2's multiplied with each other cannot combine with 3's multiplied with each other. It's not like, please, you don't even need to write this, but it is not where we can combine the 2 and the 3. This is what some people try to do. They say, well, 2 times 3 is 6, and 3 times 4 is 12. No, this is not how it works. Likewise, or sorry, not likewise, but if the bases match, watch what happens here. 2 to the third is 2 times 2 times 2, right? 2 to the fifth is 2 times 2 times 2 times 2 times 2. Do I have all the same numbers here? Yeah, we have all 2's. So we could just count up how many do we have. Well, we had 3 from the first one. We had 5 from the second one. How many 2's do I have in total? 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 8, right? So this becomes 2 to the 8th. Can anyone see what we did with the exponents? We added them. So here's the trick. A power, this is the rule that we like remember. A power times a power actually tells us to add the powers. Here's what I mean. We're going to do example problems to practice this. Power, right? Z to the fifth is a power, times Z to the sixth, that's a power. We keep the base. So here's that only if. By the way, guys, the abbreviation IFF in math means if and only if. Don't ask me why it is that abbreviation, but the abbreviation IFF means if and only if bases match. So as long as bases match, like my 2 and my 2 up here, I just add the powers together. 3 plus 5 is 8. So Z to the fifth times Z to the sixth Hannah, what would that be? If I had 5 z's from here and 6 z's from here, how many z's would I have total?
11.
Yeah! Dewan, what about this one? And there is kind of there's something tricky going on here.
They'd still be 7, right?
Oh, see, that's why I told you it was tricky. Dewan, how many A's, if I cover this up, how many A's are there here?
They're
1. So this is really A to the first power. We don't have to show a first power, but it's there. So, Dewan, you want another chance? What would we get? Yeah, A to the 8th power. Sarah, this is a weird one, but you're going to see things on Khan Academy like this. If you were given, this is literally straight off Khan. If you were given x to the 9th equals 12 to the 2nd times 12 to the 7th, can you make sense of this for us? Or do you want to pass? Like, this is a weird type of problem that you may have not seen before. Yeah, you're right that this becomes 12 to the 9th. Here's the weird thing about how Khan is asking it. It gives you x to the 9th equals this, and it asks you what is x. So if we had to answer what is x, I love what you said, that these would become 12 to the 9th, because what we were figuring out is, oh, well, x, it's asking us what is the base. And, well, the base has to be 12, because it's really checking if we know that the bases stay the same. So what it's double checking is that we know the bases stay the same. Here's another version of a problem like that. 3 to the 10th equals 3 to the 7th times something to the 3rd. Well, for these to combine, the bases would have to match, and x, our base here, would have to be 3. Because the bases would have to match to be able to combine and be 3 to the 10th. These sort of Khan Academy problems are a little bit tricky. We'll probably go over more of those on Thursday after you guys have tried the activities and can actually tell me what you is struggling, what you are struggling on. Hey Logan, I just saw your message. So I just keep rolling. By the way, because we have such limited time, a lot of what I'm doing is like repetition. So once you feel comfortable on something, if you see that we've got more repetition coming, that would be when it's a good time to go to the bathroom. Any questions on this page involving like when we start to use variables and see variables? I've got a pop quiz. Not really a pop quiz because I don't believe in those. Test yourself. Try this. What if I gave you K? Sorry, it's a lowercase k. I was trying to think of a letter that doesn't look like a number. K to the 5th times k to the x. Any volunteer? Sebastian? Yeah, we add the powers. So this is why I was kind of like pop quizzing this. This would be k to the 5 plus x. You're absolutely right. Because we have to add the powers. Now, that kind of brings up the question of when would it be 5 times x, right? Like when would powers multiply with each other? Well, good thing I have my next page of notes. Sorry, Akshaya, you got a question?
No, I was gonna answer the question.
Oh, when we actually multiply?
Yeah.
Do you want to tell me?
Yeah. So what you would do is you would put k to the fifth in parentheses, and then put this another exponent right next to it, and put x, and then multiply.
So what Akshaya is telling us to do is fine, I'll make my k like this. K to the fifth in parentheses, and then put x. So you're saying this would be k to the 5x? You don't have to write that down because you're about to write this down. You guys can unmute and tell me how funny I am, that I'm the funniest and best math teacher that you guys have ever had, and that even on Zoom, I make a bright spot in your life that is full of staying at home right now. Has anyone seen Inception? Where there's dreams inside of dreams inside of dreams, maybe inside of another dream. It's okay. You're making me feel. Thank you, Sophia. You're the only one making me not feel old as we sit here. So Inception was a ridiculous movie where they go into somebody's dream, but then from within that dream they have to go deeper into a dream from the dream, and then they go even deeper into a dream from the dream. I'm trying to make a joke.
Hold up a mirror behind the mirror, and you can see into that mirror.
Yeah, in a way, but this was literally people going into actually the beginning of Inception is super cool when the road bends up and literally goes above them. I'll see if I can find that clip after class if anyone wants to hang out and try to watch it. But yeah, so if we have an exponent on an exponent, what this is actually saying, please watch my screen so that you understand what we're doing. And I'm sorry this isn't very dark and only shows up so well. 7 squared to the 4th says repeat multiplication of 7 squared 4 times. So I have 7 squared times 7 squared times 7 squared times 7 squared. And we know every 7 squared is 7 times 7. So I really have 7 times 7, 7 times 7, 7 times 7, 7 times 7, all multiplied to each other. So what we can really say is instead of writing out all of this nonsense, 7 to the 2nd to the 4th is 7 to the 2nd times 4, or just 7 to the 8th. So our rule, and I didn't really leave much space down here, but our rule is that a power raised to another power, that will multiply. So z to the 1st to the 2nd, well, that's not very creative. 1 times 2 is not very tough. Kelly, what do you got for us? I see your hand up there. Z to the 2nd. Yeah, it's a very large number, right? That's why most of the time it's easier to just write it as 7 to the 8th. So, Kelly, since you're unmuted, what would 4 to the 2nd to the 4th become? No, don't do that. Use 4 still. You're right, but if we use 4 still, what's the power? Yeah, there we go. You're almost trying too hard, which I think is a thing drummers do because... Yeah, you can't do this one as fast. 5 cubed, well, I don't know, you might be able to do that as fast. Let's keep moving on to other people. I'm moving on to somebody else. Love you, but moving on. Rachel, what is 5 to the 3rd to the second still using 5 as our base?
5 to the 6th power.
Yeah, because we multiply the 3 and the 2. And then, guys, here's something similar to what you're going to see on Khan Academy, where they start to just be kind of crafty with you. They say 8 to the n to the 3rd equals 8 to the 6th. Well, what we're asking is, okay, so n times 3 is what made 6. What would n be? Anybody? 2. Wow. I don't know how long Cooper's been waiting. Sorry, Cooper. I don't know how long you'd been waiting. Were you with us when I was talking about exponents on exponents? Or were you... The Z's and the A's? From the last page? So, we were doing this stuff. This was exponent times exponent, like power times power. So with that, we just add the powers together, right? Add the 5 and the 6 to get 11, add the 7 and the 1 to get 8. So we can play with those, and Khan likes to put it in some different forms. And then you missed us asking just like a little challenge question of k to the 5th times k to the x. Well, we would add those. But then we asked, when would we ever multiply? Like, when would we get k to the 5x? And that is actually when we do a power to a power. So when you have an exponent value raised to an exponent, that's when we actually multiply them. I will be honest with you. I have 2 more pages of notes, like ready to go. But we're at time, right? I want to respect your guys' time. So this is where we'll pick it up on Thursday, continuing to talk about exponent work. Yeah, most everything you have in Khan Academy is all a bunch of exponent practice. So again, if you don't know how to do something, watch the video. That does not mark your answer as incorrect or anything like that. Watch the video, use the help tools, reach out to me if you still need help. I need Dewan and Audrey to hang out for just a little bit. I just got to chat with you about something real fast. And aside from that, everyone is welcome to leave. Thank you very much for coming to class. We have been commenting on how awesome you guys are and how we've been having perfect attendance. So you guys rock. Keep it up. We're excited to see you guys next week. Yeah, but I need Dewan and Audrey, so I'm actually going to... Anyone who wants to stay, I'm going to put you in the waiting room. Thank you.